So now we will discuss the questions related to chapter 10 and the most common mistake usually students do in chapter 10, that is redox reaction. So this chapter is related to reduction and oxidation reactions. So let's see one by one. When heated strongly, silicon oxides react with carbon. Which term describe what happens to silicon oxide? If you see, this is your silicon oxide, right? And in the product, what happened? The silicon is just as alone without oxygen. So what does it mean? Oxygen has been removed. So when oxygen is removed, that is called reduction. All those, there are two types of the reaction. One is reduction and the other one is oxidation. If they both takes place in one reaction, such reaction is called redox reaction. Redox reactions are those reactions in which reduction and oxidation is taking place simultaneously. Okay, so now they are not asking about the overall reaction, they are just asking about silicon dioxide, that what happens to silicon dioxide. So if you see, silicon dioxide has now no oxygen in their product. What does it mean? It means it is reduced. If it gets the oxygen, it is oxidized. If the oxygen is removed, it means that this is a reduction reaction. So option D is the right option. So what is oxidation? What is reduction? You have to remember there are three definitions for oxidation and there are three definitions for reduction. Oxidation is the gain of oxygen, just like the name. Gain of oxygen is oxidation. Then reduction is the opposite, the loss of oxygen. Okay, here we can see the loss of oxygen, that's why it's reduction. The second is, it's the gain of the oxygen, then it means it is actually the loss of electron. The loss of electrons is called oxidation, and the gain of electrons is reduction. And other term is oxidation number. Because this is oxidation, so increase in oxidation number will be oxidation. Increase in oxidation state or oxidation number actually is oxidation. But if there is decrease in the oxidation number, then it is oxidation. This is called reduction. Okay, decrease in oxidation state or number is called reduction. So everything will be lost in reduction except for the electrons. Okay, electrons will be gained in reduction, but in oxidation we will lose electrons. So now let's see the question related to this one. Which equation represent a redox reaction? So now here you can see there is no involvement of the oxygen. Can you see the oxygen is involved here? Yes, we have oxygen involved. But if you see here Ag, okay, it's a metal, and now it is getting chlorine. It is already losing this nitrate ion. But you have to look for the here now, because the oxygen molecule is not involved. So now you have to look for other two options, either the loss of electron or oxidation state. Okay, so here we will look for the oxidation state, that is more easier. If you see, what is the oxidation state of Ag here? It is +1 and NO3 is -1. If you see in the product, it is still the same. Ag is +1, Cl is -1, here Cl is -1 and this is +1, right? Na is +1, NO3 is minus. So nothing changed, no change in the oxidation state. So this reaction is not a redox reaction. Redox reactions are those reactions in which oxidation and reduction are taking place simultaneously. The trick for such question is that you always should look for the metal displacement reaction or halogen displacement reaction. If you can find the metal displacement reactions, what will be the thing in that? What is the common thing? You cannot waste your time. So what you should do, if you don't want to find the oxidation state, you should look for any equation in which the oxidation state is 0 for any element or compound. Okay, not compound, sorry, only for element. If you can find any element in a reaction and that is present in a form of element, like for example, if you see Cl2, so it means its oxidation state is 0. If you find copper, then it means oxidation state is 0 alone. Okay, so can you find any element that is all alone in the reactant? Yes, we have here, that is iron. Can you see it is not present in a form of compound? So it means its oxidation state now here is 0 because it is in the element form, right? It is not in a compound form. Now here you can see that does the oxidation state change or not. If the oxidation state has changed, then it means this is actually a redox reaction. See, the oxidation state of iron is 0 here. And now let's see here. How much is this? Oh, 4. It means oxygen is -2. So -2 into 4 is equal to -8, right? So Fe3 is also how much? +8, right? It can be +8 because this one is -8. So it means we have the same, we have the oxidation state of the iron here is one is +2 and the other one is +3. So that's why it's 6 and this. So see, the oxidation state before was 0, but now it changed to here. If you change to +8, right? So oxidation state has increased, it has changed. When there's a change in the oxidation state, such reactions are called redox reaction. So that's a simple trick. You can find that option C is the right option, okay, in which you can find an element, a reactant in the form of element, or maybe in the product you can find an element. Here you can see you can also find a product that is in the form of element, right? It is just hydrogen molecule, it's not a compound. But before, hydrogen was here in the form of a compound, that is water, right? So that's why option C is the right option. Let's see another example. Which reaction of hydrochloric acid is a redox reaction? Again, you have to look for the element that is present in a compound or in a in the reactant or in the product. If you can find any element, this is a compound, this is also a compound, and here the products are also compound, right? Again, compound, but here you can find an element and then you can find a compound. Here again an element, a compound. So we have, if you see, the oxidation state of magnesium is 0 here. But what is here now? +2. So it has been changed, right? So oxidation is taking place here. It means then there should also be reduction. If you see, hydrogen is +1 here, but now it becomes 0, right? So hydrogen is reduced, magnesium is oxidized. So this reaction is actually a redox reaction. So this is the simplest trick. If you want to find the redox reaction, first you have to look if you can find any element. Yes, if you don't find any element in any of the option, then you have to find the oxidation state. But if it's already there, any one equation in which elements are present there and also the compound, and later that element changed into a compound, right? The magnesium was element here, but now it changed into a compound. So it means this is actually a redox reaction, and this reaction we usually call it a metal displacement reaction, okay? Or but here it is not a metal displacement reaction, it's just the reaction between a metal and the acid. So that's why metal and acid reactions are also redox reaction. Option D is the right option. Now let's see which row describe what happens to Fe2 plus ions when they are oxidized. So oxidized means the loss of electrons, right? So oxidation means the loss of electrons. So what happens to Fe2 ions? It will lose the electron. So losing electrons, and if it is oxidized means, then oxidation means the gain of the oxidation number. So the oxidation number of the iron will increase, okay? Oxidation means the increase in oxidation number but the loss of electrons. So option D is the right option here. The equation for the reaction of magnesium with carbon dioxide is shown here. Which statement about this reaction is correct? Let's see one by one. Magnesium is reacting with carbon dioxide and now magnesium has taken one oxygen. What does it mean? It means when you gain oxygen, you are oxidized. So magnesium is oxidized. What about carbon dioxide? Carbon dioxide has lost its oxygen. So it means carbon dioxide is reduced, right? So now let's see one by one. Magnesium is oxidized, yes, and carbon dioxide is reduced. So this option is the right option. But we can see also other option. Magnesium is reduced, wrong. Why? Because magnesium gained oxygen. Gain oxygen means oxidation. Magnesium and our carbon dioxide both are oxidized, wrong. Magnesium is oxidized, carbon has lost oxygen, so it is reduced. Magnesium and carbon dioxide are neither oxidized or nor reduced. That's wrong, okay? Because oxidation and reduction, the redox reaction means either you lose an oxygen or gain an oxygen. So this is the first definition that fits for this equation, okay? So that's why option A is the right option. Let's see another example related to the oxidation reduction reactions. Aluminium is extracted by electrolysis. The ionic half equation for the reaction of one of the electrodes is shown. Which row describe the change in oxidation number of aluminium and the type of the reaction at this electrode? First of all, it is the reaction at electrolysis, and we already know at electrolysis we have two types of electrode. One electrode is positive and the other one is negative, okay? At negative electrode you will always get the which ions? The positive ions will move towards the negative electrode. So this reaction they have already given you, and you need to remember before the oxidation state of aluminium was 3 plus, right? It's simple, but here now aluminium is in the form of a metal. Now the oxidation are in the element form. So now oxidation state is 0. So oxidation state was higher. It was 3 plus. Now it is 0. So what does it mean? This is a reduction reaction because the oxidation state has been decreased. The oxidation number of the change in the oxidation number from 3 plus to 0 means it has been decreased. So these two options are right. Now what type of reaction is this? When the oxidation number is decreased, it means this is a reduction reaction. Okay, it is the opposite of oxidation. So that's why option A is the right option. Let's see another question. The equation for the reaction between aluminium and copper oxide is shown. Which statement about the equation are correct? Again, let's see here. It's a simple equation. You can easily see that aluminium gained the oxygen. So it means aluminium is oxidized, right? Because it gained the oxygen. This is the definition of oxidation. And copper oxide has reduced. Why? Because the oxygen is removed. So copper oxide is reduced. Now let's see the oxidation. The oxidation number of aluminium reactant is +2. We have to check. Now, aluminium is in the form of the element, right? Whenever anything is present in a form of element or in a form of molecule but not in a compound, its oxidation state is always 0. So this statement is wrong. The oxidation number of aluminium in the product is +6. Okay. Let's see what is the oxidation state, oxidation number of aluminium. O3 oxygen has an oxidation state of -6 now because -2 into 3 is equal to -6. So Al2 is +6, right? But this option is wrong. Why? Because we have 2 Al2, right? So one aluminium has the oxidation state that is +3. It's not +6, okay? Same is for oxygen. The oxidation state of oxygen here is -2. It's not -6, okay? Overall, the charge is -6 because we have 3 oxygen. Overall charge is +6 because we have 2 aluminium, but oxidation state is +3. So this option is also wrong. The oxidation number of the copper in the reactant is +2. How to? Because if oxygen, we already know that oxygen state is -2, right? So if it is -2, then copper is +2, right? Because they both are equal in number, 1, 1. So it means this option is right. In the reactant, the copper oxidation number is +2. The oxidation number of copper in product is 0. Yes, that is also right because copper is in the element form now. Okay, anything that is present in the element form or in the molecule form but not in compound, then the oxidation state is 0. So option 3 and 4 are the right option. That is option C. Okay. I hope this is clear to you that any element that is in the element form or in the molecule form but not in compound form, the oxidation state will always be 0. Let's see question 92. Which equation shows the reduction of copper? So it's simple. Reduction of copper means you will lose oxygen or either you will gain the electron. Let's see one by one. The first one is copper oxide, right? And then in the product, if you see, there is no oxygen. So it means what happened? The copper has been reduced. The loss of oxygen is the reduction. So this option is the right option. But we can look at the other option also. The copper sulfate you have first and then it becomes copper oxide. So it gained the oxygen. So it is oxidation, right? Here the copper gas changed to liquid, the liquid changed to solid. It is just the change in the state of the matter. No redox reaction is taking place. So option A is the only right option here. Let's see question 93. Which statement about reactants in redox reactions is correct? Okay, so now this question is related to oxidizing agent and reducing agent. Okay, so oxidizing agent, if you remember, oxidizing agent will always be the opposite. Oxidizing agent means anything that is reduced itself but is oxidizing another one. Okay, so an oxidizing agent will always reduce. Remember that, will never oxidize. So don't get confused. Most of the time the student get confused. They think oxidizing agent is the compound or an element that is actually oxidized. No, the agent job is always the different one. So if it is working as an oxidizing agent, it means itself it is reduced. Okay, so oxidizing agent always reduce. So an oxidizing agent donates electron. Wrong. Why oxidizing agent cannot donate electron because it is reduced. So what does it mean? It gains electrons. Reduction is actually the process of gaining the electron. So that's why this option is wrong. When one element gains electron, the oxidation number of different elements increases. Okay, one element, if it is gaining an electron, what does it mean? It means it reduced, right? Because it is gaining the electron. Then the oxidation number of a different element will increase. Yes, that option is right. Because if we have one element and this is the second element, the first element gain electron, right? So gaining electron means its oxidation number is reduced. What about the second element? Then the oxidation number of different element, that is 2, it will be increased because the oxidation number of this one has decreased, so the other one will increase. So that's why option B is the right option. But we can still look at option C and D. When the oxidation number of one element increase, for example, this oxidation number has been increased, a different element gains oxygen. Wrong. The oxidation number of one element, if it is increasing, it means it is the one actually that is gaining the oxygen. Okay, so that's why this option is also wrong. Now let's see D option. When the oxidation number of one element increase, a different element lose electron. Okay, so whenever the oxidation number of one element is increased, what will happen? Okay, if we have the oxidation number of, for example, we have two different elements. So the oxidation number of this element is increased, right? So what will happen? This different element is losing electron. No, it is gaining electron because this one oxidation number has increased. So what does oxidation number increase mean? It means the loss of electron. So the same element is actually losing the electron. So that's why option B is the right option. Okay. Question 94. Chlorine displaces the bromine from aqueous potassium bromine. The ionic equation for the reaction is shown here. Which statement about this reaction is correct? Now let's see the oxidation states. Chlorine, it's in the molecule form, so its oxidation state is 0. Here it is now -1, so it is decreased. Before it was 0, now it is -1, so chlorine is reduced. Bromine, it was -1, now it changed to 0 because it is now in the molecule form. So this one is oxidized. The increase in oxidation number means oxidized. Decrease in oxidation number means it is reduced. So let's see now, bromide ions act as an oxidizing agent. So what's happening to bromine? Bromine is oxidized. So agent job is different. It means bromine is actually the reducing agent now because it is reducing another substance, but itself it is oxidized. So reducing agent is the one that will itself oxidize. So bromine is not an oxidizing agent because bromine is actually oxidized itself. So when it's oxidized itself, it means it will reduce another substance. So this option is wrong. Bromide ions are oxidized. Yes, that is right. As electrons are lost. Yes, oxidation means the loss of electrons. So option B is the right option. Chlorine acts as a reducing agent. Again, wrong. Chlorine is reduced, means as a oxidizing agent. Oxidizing agent job is different, right? So if anything is reduced, it means it is actually the oxidizing agent. If anything is oxidized, then it means it's actually a reducing agent. So the agent is opposite of what actually happening to that compound. So chlorine is actually oxidizing agent, so this option is wrong. Chlorine is reduced, yes, as electrons are lost. Wrong. Electrons are gained. Whenever there is reduction, there is a gain of electrons. So only option B is the right option over here. Let's see question 95. In which equation is the underlying substance acting as a reducing agent? So reducing agent means any substance that is oxidized, right? So we have to check which one is oxidized. This one has one oxygen here, but now it gains two oxygen. So it means it is oxidized. So carbon monoxide is the reducing agent. But if you still want to look at other options, we can see one by one. Carbon dioxide, it has two oxygen here, but now it has one. What does it mean? The loss of oxygen. Loss of oxygen means reduction. So anything that is reduced, it is actually a reducing, it is an oxidizing agent, not a reducing agent. So that option is wrong. Copper oxide is reduced, not oxidized. Again wrong. Calcium oxide, again it is not oxidized. Okay, why not oxidized? Because it was still +2 here and here it is still +2. So this reaction is even not a oxidation or redox reaction. So now option A is the only right option in which the redox reaction is taking place, and carbon monoxide is the reducing agent because itself it is oxidized and it has reduced the iron, right? So option A is the right option over here. Let's see question 90. The equation for the redox reaction is shown over here. Potassium iodide is dash agent in this reaction because the iodide ions dash electrons. Which words complete the gaps? So now first of all we have to see what is happening to potassium iodide. What is the oxidation of potassium iodide here? If you see, K was +1 and I is now -1 over here, right? Let's see here what happens. The iodine becomes 0 here. So before it was -1, now it is 0. So loss in oxidation state, right? In oxidation number, you can say. So the oxidation number is decreased, right? Or increase. What do you think? It's increased, not decrease, increase, because before it was -1, now it becomes 0, right? Here the K is still the same. It is -2 here and the K is +1 here because +1 into 2 will be plus. So K, nothing changed to K. So now it's the oxidation state of only I is changing. So iodide was first -1. Now it becomes 0 because it is in now the element form, right? So it means the oxidation number has been increased. So what does it mean? It means it is oxidized, right? Oxidation, increase in oxidation number means the iodide ions are oxidized, right? So oxidized means it is the loss of electrons. Oxidation means the loss of electrons. So iodide ions will lose electron. Clear? So if iodide ions is oxidized, what does it mean? Which agent is this one? Agent is always the opposite one. So it means potassium iodide is actually a reducing agent because itself it is oxidized. So reducing agent and the loss of electron is the right option. So that is option C. I hope this is clear to you that reducing agent is always the opposite of what is taking place. If anything is oxidized, it means it is actually a reducing agent, not an oxidizing agent. Okay, so if you remember this one, that oxidizing agent job is different and it itself it is acting differently, then you will choose the right option exam. So reducing agent means it will reduce an other substance, but itself it will be oxidized. So that's why option C is the right option. Okay, let's see this question. The equation for the reaction of sulfur dioxide with acidified potassium dichromate is shown over here. What is oxidized and what is the oxidizing agent? If you don't want to waste your time, you have to remember this thing, that acidified potassium dichromate is already given in your book. It is written not as dichromate, but it is written potassium magnate, and they said that potassium magnate is an oxidizing agent. Potassium magnate and potassium dichromate, they both have almost same properties, so this is also an oxidizing agent. You have to remember this one, that this is actually an oxidizing agent, potassium dichromate. So if they are asking what is oxidized and what is oxidizing agent, so your answer should be potassium dichromate because that is oxidizing agent. So where you can see potassium dichromate ions, yes, it is here. So option A or D can be right. So now if potassium dichromate is an oxidizing agent, it means it will not oxidize, it will reduce, right? The job of oxidizing agent is different. So if it is reduced, who will be oxidized? It can be H2 or H, or it can be SO2. We don't have H option, we have just SO2. So that's why oxidize A option is the right option, because sulfur dioxide will be oxidized. But this is the first trick you can find the answer, and that is option A. Okay, so option A is the right answer. But in exam, if you don't remember which one is oxidizing agent and which one is the reducing agent, so you can calculate the oxidation number. Once you calculate the oxidation number, you will find that who is oxidized and who is reduced. Let's see here now. Sulfur dioxide, if you see here, and now we have sulfur tetraoxide. Can you see here that oxygen number has been increased here? Before we have 2 oxygen, now we have 4 oxygen. It means this one is oxidized, right? You will think that, oh, this is -2 and before it was 0. No. Let's check it again. SO2, if you see, O is -4, right? Because we have the oxidation state of oxygen is -2. -2 into 2, because we have 2, so total is -4. So sulfur is how much? Is positive 4. But if you look at over here, now SO4 minus 2, the answer should be minus, right? If O4 is minus 8, because we have 4 oxygen atoms and each one has the oxidation state how much? Minus 2. So this is minus 8. So this one plus 6. So you can get minus, right? So can you see the oxidation state of sulfur has changed from plus 4 to plus 6? It has increased. So increase in oxidation state means it is oxidized. So what is oxidized? It is SO2. So obviously the oxidizing agent will be the opposite one. It can be H plus or Cr2O minus. So we can just simply look at the shortest one and the simplest one, that is H plus. If you see what happens to H, H is already a positive ion here. And here if you see it is minus 2 and this one is plus 1 into, so it is same. Nothing has changed. So it means it is not oxidized, it is not reduced, so it is not an oxidizing agent or reducing agent. So we are only left with the chromate ions, okay? So dichromate ions are actually now the oxidizing agent. This is how you can find your answer, okay? This is another trick to find through the oxidation numbers. So option A is the right option. Let's see question 98. Aqueous iron sulfate is added to acidified potassium magnate. The purple color of the potassium magnate disappears. Another one, aqueous potassium iodide is added to acidified potassium dichromate. A dark brown solution forms. Which row identifies the role of iron sulfate and potassium dichromate in these reactions? So now let's see one by one. I already told you that in your book it is already given that potassium magnate is an oxidizing agent, okay? This one is an oxidizing agent. So if this is an oxidizing agent and you have added any compound and now the color has changed, it means the other compound is acting actually as it. This reaction is now a redox reaction. The other compound is actually acting as an opposite. If this one is oxidizing agent, it means this one is the reducing agent. Why reducing agent? Because the color has changed. If there was no change in the color, then it means this is not a reducing agent. Okay, so because the reducing agent will reduce potassium magnate, and that's why there is a change in color. So now they are asking what is aqueous iron sulfate, right? So it is a reducing agent. Why reducing agent? Because we already know that potassium magnate is a oxidizing agent. You have to remember this thing, because if you don't remember you will get confused who is oxidizing and who is reducing, right? Because it's already given in your book that potassium magnate is an oxidizing agent, and I already told you potassium magnate has similar properties like potassium dichromate. So if potassium magnate is oxidizing agent, potassium dichromate is also an oxidizing agent, and they are asking about potassium dichromate, okay? So potassium dichromate is a oxidizing agent. So option D is the right option. Clear? And in your book, this is already given that potassium iodide is a reducing agent, okay? Even if you don't remember this one, you have to remember that potassium iodide is a reducing agent. And if the color of the potassium iodide change, you see it was colorless and now it becomes a dark brown solution. So it means the compound that you have added in potassium iodide actually working as an opposite of this one. So potassium iodide, if it is a reducing agent, the other compound will be a oxidizing agent. So that's why potassium dichromate is a oxidizing agent. So option D is the right option over here. Let's see question 99. Hydrogen iodide is dissolved in water. Which row describe the final color seen when the solution is tested with damp red litmus paper and with acidified aqueous potassium magnate? Again, this one we already know that it is an oxidizing agent. Okay, so if the potassium magnate it is added into HI, so iodine, this one, hydrogen iodide, when will react with potassium magnate, the color will change. This is a redox reaction. Oxidizing agent, potassium magnate, has a purple color. So if it gets reduced, because it's an oxidizing agent, so it will change to colorless. So colorless is the right answer. These two are. Then which row describe the final color when the solution is tested with damp red litmus paper? It is acidic solution HI. So of course the litmus paper will remain the red. Okay, so that's why option D is the right option. The litmus paper will remain red because the iodide is actually acidic in nature. Okay, so that's why option D is the right option. So I hope these points are clear to you. You have get some tricks already for chapter 1 to 10. I will come with a new PPT that will be from chapter 11 to 21, giving all the tips and tricks related to the paper 2. Up till then, bye bye.